Welcome to Group 2's presentation on black box testing. My name is Earl, and presenting with me Briana Olsen, Leonilson Lopes, and Reece Brown. Quote is from Boris Bezer about black box testing. Anything written by people has bugs. Not testing something is equivalent to asserting that it's bug-free. Programmers can't think of everything, especially of all the possible interactions between features and between different pieces of software. We try to break software because that's the only practical way we know to be confident about the product's fitness for use. What is black box testing? Box testing is a method of software testing that examines the functionality of an application without peering into its internal structures or workings by checking the inputs and outputs of the software. This method of test can be applied virtually to every level of software testing: unit, integration, system, and acceptance. It is sometimes referred to as dynamic or specification-based testing. When doing black box testing, test cases are built around specifications and requirements, or what the application is supposed to do. Test cases are generally derived from external descriptions of the software, including specifications, requirements, and design parameters. Although the tests used are usually functional in nature, non-functional tests may also be used. Test designer selects both valid and invalid inputs and determines the correct output, often with the help of a test oracle or a previous result that is known to be good, without any knowledge of the test object's internal structure. Blackbox is mainly composed of a GUI or command line interface, which the user can use to provide the input code that is to be tested. Testing tools are usually composed of a custom compiler that is able to read, understand, compile, and execute all of the programs. The program entered by the user is fed into this compiler, and after that, the user is asked for the input variables. The user is also asked for the output variables, and this information, together with the information obtained from the compiler, is given to a dynamic analyzer. Based on the input and output values provided by the compiler, the dynamic analyzer performs the identified tests and makes the report as the output provides for the results. This is a boundary value analysis example using Blackbox. 1. The program, the input box, which accepts values between 18 and 56, and input values 17, 18, 19, 55, 56, and 57 are fed into the compiler. 2. Compiler generates the min and max values of input variables. 3. Program computes the min and max values of output variables. 4. Test the inputs values against their output values, valid or invalid. 5. Analyze where the error occur. When the program is unable to handle the min and max values of the inputs or outputs, and include these results in the report.
So let's check now what are the upsides or the advantages of black box testing. So talking about overall advantages of black box testing is the fact that this method is the closest to a real scenario. Like a user that does not know or simply does not care what's inside the software or how it works, black box emulates the user behavior. So the user simply expects an output from his input. It gives a lot of flexibility to the tester to try to simulate several forms, several ways the user can input some data. So from the overall advantages of black box testing, we can go into more details to some very specific advantages of this method. First of all, the tests are not driven by the developer. It means that the tester can work totally independently, no bias. Also, the tester does not need to have any specific technical knowledge. It perfectly emulates the user behavior because the user does not care or simply does not know what are the language, what are the technology behind the software. It simply gets an input and expects an output. So still under the user perspective, it's very easy to detect any unspecified or vague functionalities from the functional specification documentation. So that's the main source of information for the tester to try different tests. If anything it's vague, it's wrong, or it's not clear enough, it's easier for the tester to detect it.
Now that we've talked about upsides, let's talk about downsides. Some advantages of black Now we can go through specific. Now, some advantages of black box testing also lead to its disadvantage. Because we don't know what is really going on inside the black box, it makes it difficult to track the exact reason for an error. With simple code, this isn't really an issue, but with more extensive and complex code, it becomes increasingly hard to nearly impossible to track down the exact causes of an error. Now we can go through specific disadvantages of black box testing. The first is that some black box tests can be redundant. While in development, it is likely that the software is run several times to test certain things. If these same tests are run again during black box testing, it can be a waste of time and resources. Another disadvantage is that it is nearly impossible to test every single test case. Because of the nature of human-computer interaction, it is impossible to predict everything that will be entered into the program. Adding to this, complex code is nearly impossible to test with this method because sometimes you don't know what the output should be from a certain input, amongst other things. For example, if you enter 3 into the program and it gives you back Abraham Lincoln, how are you supposed to know if this is the correct output? The final issue is that if the specifications for the tests are unclear, it can be very hard to know what tests are needed to be performed.
Black box testing can be used in various ways. All pair testing is when you are testing all possible combinations of inputs to see if the software crashes. Model-based testing is used when test cases are derived from a model of the system being tested. Runtime errors occur when the system is executing and there is a crash. Load testing is when the software is put under maximum load and then the response is measured. This helps determine the maximum capacity for the software. Equivalence partitioning divides the input data into separate testable partitions. Fuzz testing is where random data is input into the software to see how it is handled. There is also boundary value analysis that was previously mentioned. Black box testing is quick and easy to perform, but is best used in conjunction with white box testing, which is identifying bugs in the internal structure of the code.